So here you learn about carbocation. Like the word suggests, carbo means you have carbon inside. Cation means it's positively charged. So C plus is what we note in this video, okay? That's a lousy grade, please don't get it in exam though. So a carbon normally will have 4 bonds around it. In this case, I'm showing a methane molecule. And you notice that methane, CH4, there's no charge. Carbon here doesn't take any charge because the formal oxidation state is 4 here, right? -4. So each of these lines represent 2 electrons, one contributed from the carbon and one by the hydrogen. So if I take half of this bond here, there are 4 electrons that's closer to carbon itself. That's why there's no charge, because carbon comes from group 4 in the periodic table. There's no difference in the electrons. However, if I remove one of these, just getting rid of one of them here, we are sure that this carbon will now take a charge. Why is that so? If you count the same way, the number of electrons that's close to this carbon, it will now have 3. 1, 2, 3. Which means that I am short of 1 than before. So when I'm losing electron, it must take a positive charge. So here we have our first carbocation in this video here. Right. Carbon taking positive charge. How do we know that this carbon will take a positive charge? You can recognize that the carbon should have 3 lines emerging out in this case. Right. Carbon group 4, so normally with 4 lines coming out from each carbon, no charge, but with 3 lines, you could have a positive charge. This is what we call a metal cation. Metal cation. Next, we could replace this hydrogen with an R group. So if I have R here, and these two are just hydrogen, it's a C plus, R being any alkyl group, okay, CnH2n plus 1, then this guy will be a primary carbocation. Primary because this carbon with a positive charge is connected to one R group, alkyl group. Or if you look at it the other way, this C plus is connected to 2 hydrogen. Next up, if I replace another hydrogen with another R group, again these 2 R could be the same, could be different. Let me just put R1 and R2. C plus. And this will be termed as a secondary carbocation. So what is a tertiary cation? Tertiary carbocation, as you have known by now, it will be replacing the last hydrogen by another R group. So let me draw it here. R, 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 positive charge. So this is a tertiary carbocation. Now with these 4 types of carbocation, we need to realize their relative stability, which is the most stable. Tertiary carbocation are the most stable because this carbon here with a positive charge lacks electron. R groups are the alkyl groups. They are electron releasing. They will push electrons to it towards the carbon and reduces the positive charge on it, which makes it very stable, lower energy. For this secondary carbocation, there's only 2 sources of electron pushing it towards the carbon. Compared to this, not so good. And again, you go down to a primary carbocation, there's only 1 set to push electron, so it's worse than this. And methyl radicals are very unstable because there's no help, no electrons that's being pushed to lower the positive charge on this carbon. The relative stability of carbocation is very important because it will allow you to think through the kinds of reactions and different products that you will form when an alkene or some other molecule react with a particular reagent.